Hi, Intro to Complex and Solving by Square Roots Day 3. Today we're just going to do some investigation with I, as well as finding solutions to imaginary solutions to problems. To determine whether a complex number is a solution or not, simply plug it in. So we'll replace x with the value -I. Plus 9 equals 8. So that means I get the negative square root of -1 squared plus 9 equals 8. So when I square the negative, it becomes positive. When I square the square root, it is removed. What's left is -1 plus 9 equals 8. -1 plus 9 is 8. 8 equals 8. Therefore, that is a solution, yes. Again, we'll be substituting the complex number 3 plus I into x across the equation. 3 plus I squared minus 6 times 3 plus I plus 10 equals 0. This becomes 9 plus 6I plus I squared. That's a perfect square trinomial. A squared plus 2AB plus B squared. Distribute, we get -18 minus 6I plus 10 equals 0. Combining like terms, we get 1 plus I squared equals 0. I squared is -1, so 1 minus 1 equals 0. 0 equals 0. Yes, it is a solution. Solving quadratics. Remember, there will always be two solutions when you square root both sides. So to get rid of the square, I'll be square rooting. So that is x equals plus or minus the square root of -36. X equals plus or minus I square root of 36. X equals plus or minus 6I. Moving the 4 to solve for x by subtraction. X squared equals -4. Square root both sides. If we don't do the same exact steps we do before, at least writing them out, you will still get the same answer. X equals plus or minus 2I. Moving numbers, 2x squared by using subtraction. Moving the number 5 also by using subtraction. 6 minus 2, 4x squared equals -4. Divide out your 4 to both sides. X squared equals -1. Square root both sides. You get x equals plus or minus square root of -1. Remember, the square root of -1 is the value I, so x equals plus or minus I. If the one solution, 3I, is a solution to the quadratic, the other solution is known as the complex conjugate of the original solution. Therefore, the other solution is -3I. Remember, the complex conjugate of a complex number, if the complex number was A plus BI, is A minus BI. The real parts stay the same, the imaginary parts switch symbol. Graphically, what does it mean when the solutions of a quadratic are imaginaries? That's when the parabola doesn't touch the x-axis at all. three possible ways. You can have two solutions if the parabola crosses the x-axis twice, one solution if it touches it exactly one time, or two imaginary solutions if it does not cross at all. Following questions, just more practice with imaginary solutions. Subtract 4 to both sides. X squared equals 4. Square root both sides. X equals plus or minus 2. Subtract 8 to both sides. X squared equals negative 4. Square root both sides. X equals plus or minus 2i. Subtract 9 to both sides. 1/2 x squared equals negative 1. Multiply both sides by 2, and you get x squared equals negative 2. Square root both sides. Two solutions. X equals plus or minus I times the square root of 2. Subtract your 5x to both sides. Subtract 18 to both sides. You get 9 equals 3x squared. Divide by 3. X squared equals negative 3. Square root both sides. X equals plus or minus I times the square root of 3. Most important thing to remember is when you square root both sides, you get two solutions. If you square root a negative number, the imaginary number I must replace that negative, and you simplify the square root as much as possible.